Inverse trigonometric functions are basically inverse functions of sine, cosine, tangent and other 3 trigonometric functions. However, here the interesting point is that because sine theta, cosine theta and for that matter other trigonometric functions, they are not 1 1 on 2 function. Therefore, inverse of these functions never exist. As a matter of fact, inverse function is only possible if your main function is 1 1 and on 2. Therefore, one cannot find the inverse function of sine, cosine and tan in totality. However, what should we do in order to find the inverse function? That is somehow to make these functions sine theta, cosine theta and other trigonometric function as 1 1 on 2. Therefore, what we will do is we will curtail the domain of these functions in such a way that the functions are 1 1 and on 2. For example, sine theta function is basically like this. However, by horizontal line test, one can see that if I draw a horizontal line, it will cut the function at various places. So it's not 1 1 on 2. So what we will do is, we will take only this portion of the domain, that is this to this portion only. So sine theta as such will be confined to only this portion, which is negative pi by 2 to pi by 2. And once I take only this portion of sine theta, then it's 1 1 and on to both. And therefore, then inverse is defined. So, in order to define inverse of sine theta, one thing is that we have to curtail the domain of this function to negative pi by 2 to pi by 2. Now, if you see the horizontal line test, you will find that it's a well defined. And therefore, sine theta domain is negative pi by 2 to pi by 2 and it's going to negative 1 to 1. Whereas inverse trigonometric function sine inverse theta is from minus 1 to 1 and then the range is minus pi by 2 to pi by 2. Likewise, cosine inverse also same logic, same principle, that is curtail the domain of cosine theta in such a way that the function is 1 1 and on 2. And therefore, cos inverse theta will be from negative 1 to 1 1 2, this time it will be 0 to pi. So that's our cosine cos inverse function. Likewise, one can define other trigonometric inverse functions also. Now, in general, when you have an inverse function, then FOF inverse of x is equal to x, which is equal to F inverse OF. That is a composite function of two functions will be equal to identity function, I can say. Now, here you have to be slightly careful that normally I can always say that sine of sine inverse x is x, at the same time sine inverse of sine of x is equal to x. That is also true because sine inverse is an inverse function of sine. However, one has to be very careful while calculating this value. You have to check that it should not be outside the domain or the range of the sine inverse function. Whenever you find the value, it should not be outside the range of this. Now, let's see some example. Let's take a question where I have to find sine inverse of sine of, let's say, 3 pi by 2. Sine inverse of sine 3 pi by 2. Okay. Now, sine inverse sine of 3 pi by 2 is not 3 pi by 2. That's wrong. Why? Because sine inverse range is negative pi by 2 to pi by 2. Right? Negative pi by 2 to pi by 2. And therefore, you cannot take the value 3 pi by 2 which is outside the range. So, what should you do? First, you find out sine 3 pi by 2. Okay. And then say find the value of sine inverse in such a way that the value is between negative pi by 2 and positive pi by 2. That's the trick. In fact, that says something important which one should follow. So here what we'll do is, what is sine inverse sine 3 pi by 2? I can write it as sine inverse sine 3 pi by 2 is same as sine of negative pi by 2. Same thing. Okay. What is the advantage here? Because sine inverse sine I will write down as negative pi by 2, which is well within the a range of sine inverse function. So what you do is you transform this value in such a way that the value is always inside the or on the range of the inverse function, whether it's a sine inverse or cos inverse or other trigonometric functions.